Welcome to the Ricci Flow Nutrition Podcast. My name is Cameron Borg. On this episode, I had the pleasure of speaking with Gaétan Chevalier. Gaétan is an expert in engineering physics, atomic physics, and laser spectroscopy. He is a world-leading expert on the effects of earthing, otherwise known as grounding, on human biology. Gaétan has been involved in earthing research for over 20 years and founded the Earthing Institute. He spent 4 years of researching plasma physics and nuclear fission at UCLA, and then served as a professor at the California Institute for Human Science. Dr. Chevalier is currently the lead faculty member at CIHS, visiting scholar in the Department of Family Medicine and Public Health, School of Medicine, UC San Diego, and director of the Earthing Institute and research director at Psy-Tek. For those who don't know what earthing is, it's essentially a process where we place our bare skin on the surface of the earth or immerse ourselves in natural bodies of water. Our ancestors were earthed essentially 100% of their lives, and in the last century, modern humans have almost permanently disconnected from the electronegative surface of the earth. Although this sounds peculiar, there are many studies showing broad beneficial physiological effects when earthed. It's important to remember that being earthed is the normal and expected state for our bodies, and our large-scale migration indoors has prevented us from this environmental influence. With all this being said, I hope you enjoy our conversation. Gaétan, thank you for giving me some of your time today. I'm really looking forward to digging into your brain and getting a bit of an idea of your ideas about earthing.
Thank you for having me. I'm very pleased to be with you today and to share some information with you.
Awesome. So you have a very interesting background. Maybe you can give us a background on where you started and how you got into looking at the biological effects of earthing.
Yes, it's a long story. I definitely did not start in this field. I was interested in physics and engineering, so I did a PhD in engineering physics from the University of Montreal, and I will always been fascinated with light, so I became a specialist in light, basically laser spectroscopy. Spectroscopy is the analysis of light. So I became a specialist in analyzing from light emitted by different elements and molecules. You can determine which molecules and which concentration they are. And also I was interested in plasma physics. And so that led me to actually be hired to work in nuclear fusion, which is basically the contrary of nuclear fission. Fusion means you fuse together two small atoms. Fission is you split a large, heavy atom like uranium into two smaller, and some energy is released, and that becomes a nuclear reaction. The other way of doing it is to actually take two isotopes of hydrogen. Hydrogen is only basically a proton with an electron around it, but you have also some isotopes called deuterium and tritium. So the deuterium has one neutron, and the tritium has two neutrons. So if you mix deuterium and tritium together, and you put them in a machine that can accelerate them to high energy, which is a tokamak can do. Tokamak basically is a Russian word for like a huge donut. And you put the gas into this huge donut. And the reason why it has to be a donut is because they're going to accelerate the energy so high that it will melt, not only melt, evaporate anything instantaneously. We have to bring the temperature of the gas to 10 million degrees just to start the reaction. So that gives you an idea. At 10 million degrees, nothing, even tungsten evaporates like this. So it has to touch nothing. But then what happened is that when you get that energy, then the tritium and the deuterium fuse together and become an atom of helium and emit one neutron. This is exactly the process that is happening in the sun. You know, the surface on the sun is only 6,000 degrees, but the inside of the sun is 30 million degrees. That's where the nuclear reaction happens. So if we're able to do that, then we don't have dangerous radioactive products like we do when we split uranium. When we split uranium, the two atoms that are left are still radioactive. So that means they're still dangerous. But the only end product with nuclear fusion is helium. They call it the laughing gas because, if you can inhale that and it changes your voice, it's just funny. It's nothing. So that's why there's been so much effort into getting fusion, because it's clean energy. So I was in this field and in Canada, in Montreal. Actually, it was the only large machine was Tokamak-de-Varennes, which was a little suburb of Montreal. And then I got hired at UCLA doing research in a specialized machine that specialized with the plasma wall interactions, because it's crucial that, the plasma, which is basically, ionized gas. At these temperature, the gas get ionized. So that means they lose their electrons. Most of the matter in the universe is actually plasma. Like the sun is a big ball of plasma, basically. A neon tube inside, it's a plasma. Okay.
Am I correct in thinking that a plasma is where the thermal energy input is so much that basically the protons, the neutrons, and the electrons all wander away from each other? The forces that bind them together are overcome by the thermal energy input.
Not the proton and the neutron. We're not at that stage yet.
Right.
We're at that stage where the electrons that circle around the atoms are ripped off.
Yeah.
But the matter itself, like, for example, if you had like deuterium or tritium or, hydrogen, they stay these elements. It's just that they're stripped of their electrons. It's not high enough yet to get to that level. Okay, like a neutron star, for example, the pressure is so high that is the molecules and the nucleus of the molecule or the atoms are fused together. That's why they call that a neutron star. But that takes enormous pressure. So it's not quite there. Anyway, so I got hired to work as a specialist in plasma wall interaction. We had a special machine at UCLA to try what would happen if the wall is made of different materials. So we were trying to use materials that are very light, because if the plasma move too much and touch the wall, then you get impurities. You get some molecules coming in or atoms coming into the plasma. These radiate energy like crazy and then cools off the plasma. We don't want that. So what we were trying is like carbon, boron, very light elements to try to mitigate them. But while I was working at UCLA, I always been also interested in yoga, in spirituality, and things like that. And so I was also part of a group, called Transmission Meditation, and we were helping them, and they have a magazine called Share International. And in this magazine, there was an article about a Japanese Shinto priest, parapsychologist, and scientist doing research on meridians and chakras. And he was using machines. He developed a machine called the apparatus for meridian identification to measure the meridian. He also had a shielded room, and he was measuring, the electric fields coming out from the body, analyzing that. And I thought that was interesting. And there was an address at the bottom of the article. I decided to write, not knowing what would happen. I just said, I would like, this sounds interesting. I would like, if it's possible for me to do something on my side, of the Pacific Ocean. So to my surprise, I got a response from one of the associates of Dr. Mutuyama telling that he's coming to have a workshop in Santa Monica. which was not far from where I was. So I decided to go. And so I met the man. The lecture was difficult to understand. His English was a little difficult to understand. Later, I understand that the man speak also German and Japanese, of course. But doesn't matter. I went to him and I said, okay, what is there a possibility of me doing some research on this topic? And he just looked at me and he said, I'm starting a school in San Diego. Uh, and I need someone who could teach electricity and magnetism, which was interesting. I just passed the course. The only course, when I was a graduate student, the only course I taught as a graduate student at Polytechnic School in Montreal was electricity and magnetism for engineers. So I said yes. So, and then I started to teach at coming down in Encinitas, where I live presently, coming down on the weekends, teaching the course to 3 students. And that was in the fall of 1992. And I didn't know it was the first quarter of the school, basically, it was open. That was open. And that was the only 3 students. I've done that for about a year. And then Dr. Mutuyama offered me a job full-time at his new institute. And that was like, wow, a huge change in career. I mean, I'm going basically from studying, plasma nuclear fusion to now electrophysiology, measuring the meridians. And, in 1992, it was considered, like woo-woo science. It was not really taken seriously, especially here in the West. So, but I knew it was my calling, so I came. So I started to teach at the California Institute for Human Science. I joined full-time in 93. And then about 10 years later, a little less than that, at some point, this gentleman came in. His name was Clint Ober. And he talked about grounding, earthing, the benefits of being in contact with earthing. At that time, there was only one study that was done that he did with a nurse. And it was mainly questionnaires. So basically, he would have people fill a bunch of questionnaires about pain and how they feel and things like that before and after sleeping grounded for a number of nights. And he was telling us, the sleep improve, less pain, and all of these benefits, more mental clarity, all these things. And I thought to myself, well, if this was the case, it would have been discovered 100 years ago. I mean, this is so simple, I thought I was surprised that this is kind of a new thing, So I let it go. I didn't do anything. But one of the, assistant of Clint Ober came to me and said, we want to do a research study. And we're willing, to pay for that. So I said, okay. We're in open school, we were actually, California Institute for Human Science was designed by Dr. Mutuyama, especially, to study things that are less conventional and so more open. So I said, sure, we'll do it. So we did the study and we had really good results, improve in, just like Clint was saying, the people were more relaxed, their muscle were working better, brain function was improved, and all of that stuff but I was still not totally convinced because the equipment we were using was grounded and the person was grounded. And I know from my PhD that if you have grounds, equipments, many equipments ground at different locations, you can have ground loops. So that means the current flows and that could interfere with the proper functioning of the equipment. So I thought, well, maybe. So Clint was aware of that. So later we replicated the same study with equipment that was not grounded, was battery powered. The data was transferred to the computer by fiber optics. There's no question that there was no ground loop or anything like that. And we got, again, excellent results. All of these results are actually published. in 2000, we published them a little later in 2006. But and two of my friends participated to this research project. Both had arthritis in the hands, and one of them had really bad, like from a level from 0 to 10. I asked him, how was it? He said 8. I said, you don't show it. He said, it's always like that. Medication doesn't work for me, things like that. And so we put patches on his hand. And Clint and I talked with him. About half an hour later, we asked him, how is it now? He said, wow, it's amazing. It's about a tree. And I said, nothing can do that. I mean, with all the results and everything, finally, how skeptical can you be? So at some point, I said, well, this is for real. And so that's when I started, And in 2007, after doing several research projects for him, Clint decided to open, it would be nice to open an institute, that is dedicated to spreading the information about earthing that is not product related. It's just about the science and spreading the words and, testimonials and all of that. And I decided to accept, to be the director. And we've been growing the institute since then. And we just actually finished the level 1. You just publish or make available on the Earthing Institute level 1 because we created a certification course, Earthing certification course, so that there's so much misinformation out there. So people can take that course. Level 1, we're going to have 3 levels, but level 1 already, have the basic information that people can do to properly ground and get a certificate. This was actually asked for years. Health practitioners wanted to have that because they want to help their patients and they want to have some credibility when they talk to their patients. I mean, getting certification is pretty current there. When you have certification in nutrition, nursing, all of these things. So we finally find the right person. I didn't want to do it by myself because I think that the woman has to be represented, being, the majority of people actually will buy earthing products. So we wanted to have, and so we are 2 hosts in that. So me and Katarina Brzovic, who is the representative of Earthing, Earthing.com, the company in South America. So we did, and the level 2 should be available probably early next week, end of this week, early next week. We're almost ready.
Excellent. So fundamentally, how does earthing work? What is happening when you are barefoot out on the grass or the soil? What's happening in the body?
Okay, what's happening is that we receive electrons from the earth. So electrons, is what flows in the current, of our houses. But the earth itself is like a large, immense battery. The battery, a battery has 2 poles, a negative pole, which is full of electrons, and a positive pole, which actually lacks electrons. I mean, it's not like you have an extra positive charge there because you lack electrons, because it's always the electrons that move, unless you are in a liquid where molecules can move. If you are in a solid like copper and things like, it's always the electrons, or in the soil, it's always electrons that move. So what happens is that the negative pole is actually of the battery, the earth battery is actually the surface of the earth. And the positive pole is about 60 miles or 100 kilometers up in the atmosphere. It's a zone of the atmosphere called the ionosphere. And it's called the ionosphere because it has ions. And ions are charged molecule. Just like what you had in a nuclear fusion plasma, we had ions there. Charged molecules that have lost electrons and now become charged positive. And all of this system is constantly powered by the sun. So the sun rays, we know, you probably heard that sun rays has a lot of UV light in there, ultraviolet light. So we are protected by the higher zones of the atmosphere. But the way we are protected is that some molecules there absorb the UV light. And UV light is so strong that it's actually split a neutral molecule into a positive and negative. And so by a very complex system involving thunderstorms and other processes like rain also, but thunderstorm is the main one, the electrons are transferred to the Earth through this process that happens in the clouds. That actually, it's like a Van de Graaff generator. Van de Graaff generator is a machine that can actually build up a lot of charge by physical means. So something similar that is not yet totally understood happen in the clouds, building up the negative charge at the bottom of the cloud and positive charge, like separating the charge, building up the potential, electric potential on the cloud to millions of it, 5 million degrees. And then eventually the potential between the surface, the lower part of the cloud and the surface of the Earth is so large that you get an electric discharge. It's like an electrostatic discharge. That's a lightning. And it transfers electrons to the Earth. And that's how this process happened constantly. Most of these clouds or thunderstorms are over Africa and South America. That's why it's so important, the Amazon and all this region in South America. It's very important and also in Africa. These are very important because they are the generators, if you will, the main generators that maintains the electric charge of the battery that is the Earth. The scientists calculated that if it would take only 45 minutes for all thunderstorm to stop for the charge to dissipate and having no charge, which would be really bad for us. So that's the way. So when we touch the Earth, we become at the potential of the Earth, and we get the electrons from the Earth. And when we're not in contact with the Earth, we automatically lose electrons, especially if the weather is humid. We lose electrons to the atmosphere. Why? Because the atmosphere is charged positive. See there, even in fair weather, there's no clouds or nothing. There's still a huge potential difference between the surface of the Earth and the ionosphere, right? It's about 500,000 volts, 250 to 500,000 volts. It's a lot of electricity. Think about the fact, at least here in North America, the voltage on the power outlet is only 120 volts. How much is it in Australia?
240.
240. See, but it's nothing.
Yeah.
I mean, 240 volts, when you are at the surface of the Earth, if we take the zero potential to be the surface of the Earth, then the electrical potential grows by about 300 volts every meter, every 3 feet. 300. So when you are in a high-rise building that is, let's say, 10 meters above the ground, then your voltage there is 3,000 volts, the voltage there. Why we don't zap, we're not zap or anything, it's because the air is neutral. There's not much electric charge there, okay? And the air is a very good insulating material. But it will break down. I mean, and when you walk on the carpet, you can, the Van der Graaf effect happens where there's separation of charge, and you build up voltage on your body. You can build up to 30,000 volts. That's why when then you touch a metal knob, you get a discharge. It's because you have lost so many electrons, okay, that it's actually the knob that gives you electrons because of the difference of potential. And when you think about that, I think that the breakdown voltage for the air is about, I think it's 11,000 volts per centimeter. So that means that you need a really large voltage to get this spark. Okay, and it's not that difficult to do.
That's really fascinating. So what are the implications? I know you've written about this before, but what are the implications of living in a high-rise building or an apartment building where you're not on the ground floor, you're further detached? How does that voltage between you and the zero potential of the surface of the earth, how does that impact the physiology of the body?
Yeah. So what we first, I want to mention something interesting. It's related to what we're talking about. Is that I've read many papers. There's been a lot of research trying to explain why people living in high-rise buildings have poorer health than people living in the low levels of the high-rise building. And they thought that the air of the of the ventilation system is not good and this and that. But another simple explanation is that the air is charged positively. So when you breathe in that air, you're breathing air that are lacking electrons. So just breathing in air, you're losing electrons to the atmosphere. So you keep losing electrons. What you do is you're building inside your body what they call smoldering inflammation. It's like low-level inflammation. It's like oxidative stress building up in your body. So that means the oxygen, is a very reactive atom. When it lacks electrons. So when you're breathing that oxygen coming in, which lack electrons and goes inside your system, you're building up automatically this smoldering inflammation slowly and slowly, and whatever. Then what happened at some point is that there's going to be a breakdown because you don't have enough electrons to maintain things together. It's like you're having acid in your body. When you pour acid on something, it dissolves because it steals electrons from the material. And so something happened like that inside of you, not very good. So, but something's going to give up. It depends. Now they found since year 2000, it's interesting because at the same year that Clint has done his first research project, medical science has done research, started to do serious research on the importance of inflammation in the body. And then since then, there's been thousands of papers showing that most of the disease, especially the old age diseases, are inflammation-based, like arthritis, autoimmune disease, Alzheimer's, diabetes, most cardiovascular problems, even cancers. So all of these things need inflammation to start in your body. So depending on your genetics, something's going to give up. Now, the body is very intelligent. It knows that it's missing electrons. So what the body is going to try to do, going to try to preserve the internal organs so that you can survive. But you're lacking electrons there too. But you cannot impair the function of these organs or you die. So what the body does, it will steal electrons to other parts of the body that even though they're not going to function properly, you're still going to survive. And what is that? The best one that the body use? Bones. So what happened? You get osteoporosis. It's the body to try to mitigate, the lack of electrons. So if you want not to have osteoporosis, just be grounded because now the body will have all enough electrons. I mean, we're avoiding so many problems, by being grounded. So many problems.
I think the osteoporosis problem has been published. I think the SoCal duo in Poland has published
something. Yeah, when I SoCal about calcium, yes, about the calcium absorption and resorption into the body. So we're losing calcium when we're not grounded because the body needs the electrons. That the electrons that bound the calcium makes the bone solid. Now these electrons are used to save internal organs that are vital for our survival.
And this process is happening at an increased rate if you're living on the 12th floor, for instance.
Exactly. That's exactly what's happening.
That's fascinating. And it's interesting to think how carefully the body balances positive and negative charge. I mean, think about the pH of the blood, for instance, has to be within
Yes,
such an enormously small range. And
that's another thing. Yeah.
you think essentially what pH is talking about is the relative abundance of protons and electrons. And when you're putting your body in a state that is physiologically abnormal, it has to do things to buffer that. And it's sort of
Exactly.
triaging the body to say, well, the things that are going to kill me fastest take priority, but the things that are going to cause chronic disease, we have to let them go because we need to preserve the organs, like you said.
Yeah, yeah, exactly, exactly. So it's very important. Now, it's not a panacea that does everything,
Mm.
but it does so much important things. It's like, if you're missing vitamin C, if you go way back a couple of centuries ago, when the people on the boats, in the marine, they had like all kind of different problems, and it was caused. If I was found that it was caused by lack of vitamin C. So lack of vitamin C will give you all these different symptoms that you can try to isolate and understand separately, but you'll never understand the real cause. The real cause, you need vitamin C. So it's the same thing here. You have all these things that happen, and people are trying, to understand how we can mitigate arthritis or diabetes and things like that. But the cause is lack of electrons. We need just electrons. So we call that the contact with the ground, we call that vitamin G.
Mm.
It's like it really act like a vitamin, really.
And the fact that earthing seems to play an important role in so many different things, we're talking things like hormonal balance, circadian rhythm, like you said, osteoporosis, so mineral balance in the body, all of these disparate things are being affected.
Menopause also, very important. When women have been grounded during their menopause, nothing, no effect at all.
Interesting. So it
It's not normal.
seems like what we're looking at is basically that earthing or grounding is the normal physiological state, and we have basically detached ourselves from what our bodies expect on a day-to-day basis, in and out. Our ancestors would have been earthed essentially 100% of the time. So we would have evolved expecting that influx of electrons whenever needed. And the moment we detach from that, uh, things get thrown into chaos, basically. And this is why so many different things are affected by the same process of this earthing. So
I
it's
could
not
not say it better. That's exactly it.
it's very
That's exactly.
parsimonious. It affects everything across the whole body because it is so evolutionarily expected
Yeah, we
from a physiological
evolve.
point of view.
Yeah, we evolve with the expectation that these electrons will always be available, and that's why we develop an immune system that use acids to kill bacteria. Because when you have, and let's say you have a scratch and you have an infection, so then the immune system, the white blood cell goes there, and they engulf the bacteria, or they spread acids on them. But when they engulf them also by, even our digestion is made by acids. We digesting by acid, but the bacteria are also digested by acids by their white blood cell. So what happened is that after that, when you had an infection and you have all these white blood cells there, neutrophils and all the others, well, you have a region where there's a lot of oxidative stress where you're lacking electrons. And it's planned that we have a supply of electron that will come here and will mop up that, and everything will be okay. So that's why in the natural world, inflammation does not exist. You don't have it. You need inflammation is a response again from the body to try to mitigate the effect that you have this region where there's a lot of positive charge because there's been an infection or something. Okay, I don't have the electron to cancel that. What I'm going to do? So the first thing I'm going to do is bring some fluid there, so that try to dilute the concentration. That's why you have inflammation. You have like fluid there. So bring the fluid. Then another thing that Anne Sellier, a researcher in physiology, has found is that it's going to create a pouch around it, try to isolate it, you see, so that these positive ions don't go anywhere in the body. So the body is trying its best, to try to mitigate that when it's lacking the most fundamental things that it needs to to resolve the situation, which is something that was expected all the time. But if you have electrons, you don't have inflammation. You don't need inflammation. The bacteria, the red blood cell will go engulf the bacteria, whatever. Pus, you will have pus, and it will be it. There will be no inflammation at all.
How familiar are you with the work of Robert O. Becker?
Well, I read his books, two of his books, I think he was onto something very important.
It seems to me like this story, that the earthing, this earthing story gels quite well with what Becker was talking about.
Yeah.
He makes it quite clear that the extremities of the body, for instance, hold more negative charge than the closer to the center. And when you get that current of injury, when a broken bone happens or you split the skin, that charge shifts quite a lot, basically as a signal to recruit the white blood cells and the red blood cells.
That's right. It becomes negatively charged to recruit the white blood cells so that they go there. It's perfectly in harmony with what we do. There's another scientist that now is kind of continuing the research, which is very interesting. It's about now using electric voltage and current to manipulate gene expression. His name is Michael. I'm forgetting his last name. We talk about a book called "We Are Electric" by Sally Adee, and his name is Mike Levine. And he was able, for example, by manipulating electric field, to have an eye grow on the side of a fish. So it shows that when an embryo is developing, electric fields are created that are absolutely fundamental to the proper growth of the embryo. If you disturb that, you will have, distorted body parts and things like that. And he was able to show that. It's very fascinating research. And so we're just starting to understand with all of these things the importance of the body as an electrical device, just like a computer, but it's a bioelectrical device. We found about 10 years ago that the vagus nerve is controlling, not only the autonomic function of the internal organs, but also controlling hormonal functions and even immune function. So everything even the biochemistry is actually controlled by bioelectrical signals. And we're finding that more and more. So we are bioelectrical beings.
Yeah, I know, for instance, that you can't, embryos won't develop in a Faraday cage. So, it's very clear that our form and the expression of genes and the control of our responses to the environment are all mediated by this the very subtle electromagnetic signals from our environment. So how do you feel about the world that we live in now that is so polluted with non-native electromagnetic fields? How do you think this might be affecting us?
Okay, yeah. So I would like to start with which one are the most fundamental electromagnetic field that we are exposed normally in the wild. One is the Schumann resonances. And we know now the Schumann resonance at 7.83 hertz. And from a physics standpoint, it's easy to calculate because you take the speed of light divided by the diameter of the Earth, and it's 7.8. So that means that the light goes 7.8 times around the Earth, in 1 second. It's very fast. And it's reflected mainly by some layers in the ionosphere, again, these electromagnetic fields. So the brain is adapted to that. So now, the interesting thing is 7.8 hertz is right between so we have, the highest frequencies are in the beta. It's about 20, 30 hertz. Then you have alpha, which is about 10 to 20. And then we have theta, which is like 5 to 10. And it just happened that the Schumann resonance is between, just at the cusp between alpha and theta. So it's a very calming frequency. You can, for the brain. That's why when you go in the forest and you go outside for many hours, much more calm. One of the reasons, there's many reasons, of course, we get the sun and we get vitamin D, we get the ground, but we also get that Schumann resonance that our body is designed to be in responding to. Now, in our homes, what do we have? 50 or 60 hertz cycle bombarding us day and night. So what happened to people? People are just like, I have to do this, I have to do that. People are on high speed, every life is the society, more and more moving. It's because it's too fast. It's too fast. So our brain is ain't trained to think nonstop. How many people can think, and they cannot stop? Most people are like that. That is, you go in nature suddenly, it's not like that. You can be relaxed. It doesn't matter anymore. Blah, blah, blah. All the problems that we're like, it's not so bad out there. It's like, so that's one thing. The second one that is very important, we found that also with the research that I've done, Valerie Hunt has done at UCLA, is the geomagnetic field.
Mm-hmm.
Now, you have to understand that these fields, the Schumann resonance is difficult to measure because it's so small.
Mm.
And yet the body zooms in on that and feeds on that. The same thing with the geomagnetic field. Geomagnetic field is basically, you can also see the Earth as a gigantic magnet, right? Has a North Pole and a South Pole. And the magnetic field normally, is strongest to the poles, because it come in and out from there. But you would say that on average, it's probably for most people around 0.5 Gauss. And I forgot how many Tesla. It's very small. And 0.5 Gauss is very small. I mean, there's no magnet that are that small. What's interesting is that there's a fluctuation of this little magnetic field that is so small that is about 1,000 times smaller than that. And yet we are synchronized to that.
Yeah.
If you go into a Faraday cage that is also made of mu metal, that cut also, because normal Faraday cages made of, like copper, and does not cut the geomagnetic field. It will cut the 60 hertz and things like that.
Yeah.
If it's done properly. Most don't even cut the 60 hertz because it's so low. It cuts all electromagnetic field due to cell phone towers and stuff like that. But the California Institute for Human Science, we have a shielded room that also has stainless steel, so that it cuts not only the electric field electromagnetic field are made of electric field and magnetic field. It's easy to cut the electric field. You just need a sheet of aluminum foils and it cuts the electric field. But at 60 hertz, the wavelength is so long that the magnetic field goes through and regenerate the wave after. So
right.
what you have to cut the magnetic field too, if you want to cut the 60 hertz. So you can do that with a ferromagnetic material like stainless steel. A ferromagnetic material can be put next to a magnet and will become magnetized. So that's a ferromagnetic material. You need that. Most Faraday cage don't. But even that is not enough to stop the geomagnetic field. Now you need a mu metal, a metal that it really absorbs magnetic field really strongly. So Valerie Hunt has one of those special Faraday cage, if you will, with mu metal, which is very expensive, by the way, at UCLA. And so she put people in there. And after about an hour, most people want to get out. They feel bad. They feel, like they cannot stay there. So what she did is that she generated a very small magnetic field inside that Faraday cage to see what happened. And then people can stay longer. So we do feed with this geomagnetic field too. That's why they talk about the reversal of the geomagnetic field, and it's going to influence the entire life on the planet. It happened in the past, and it's normally when there's causing upheaval in natural world, some species to disappear, some others. So it's a natural phenomenon, but it will affect us because we need it. We need that geomagnetic field too. So these are the two ones that we really need, that we know that a response is, we don't have them, we do have some problems. So now the interesting thing, can I just finish one more thing?
Yeah, please.
The interesting thing is that when you are grounded, even if you're grounded in your home with a grounding mat or something, you get not only the electrons, but the electrons vibrate at certain frequency, which include the Schumann frequency. So it calms you down also.
So does the vibration of the electron that you are getting when you're earthing the electrons, rather, does that vibration change depending on where you are on the earth? And is that a way in which our bodies understand where we are on the earth? Is that a way that we can set our rhythms, so to speak?
Yes.
So
yes,
the vibration of the electrons is our bodies pick up on the specific vibrational energy. Wow.
Of a location. We don't have a specific research project, but we do have many people who travel. And let's say you're in Australia and you come to California. So there's going to be a huge, time difference and people get jet lag and stuff like that. Well, you put your feet on the ground for 30 minutes here in California where you are. The body will pick up the frequencies of what time it is during the day and stuff like that and readjust in its internal clock so that you don't have any jet lag. And we have many testimonials of that. So yes, so it's more, grounding is more than getting electrons. It's getting also some information that the electrons and that electrons carry, and that the body is designed to understand and to translate into what is needed for it physiologically, because this has been happening for the millions of years.
Now, for anyone who's been interested in earthing for a while, they've probably tested their total body voltage and watched it drop down to zero when they get earthed, which is quite interesting when you're next to it. Let's say you've got your computer plugged into an AC outlet, and you watch your total body voltage go really high the closer you get to it, and then the moment you ground, it drops to zero.
Yeah.
Why then is it so important, and it's stressed in a lot of the research papers, that it needs to be done for about 30 to 40 minutes to really get the full benefits?
Yes, because we have a paper that was published, I think in 2010, where we measure a lot of physiological parameters. We measure heart rate variability, we measure respiration rate, we measure blood oxygenation. And what we found, and also the stress at the surface of the skin conductance, what we found in this study is that when you ground a person, it takes 1 second or two for the body to react and change the function of the autonomic nervous system within 1 second or 3 seconds maximum. It's not instantaneous, so it's not a purely electrical effect, because it would be instantaneous, but it's not instantaneous. It takes a second or two or three. So that leads me to realize that when you get that, the body gets the information, said, we are now in the natural state that we're used to. So there's automatically, within a second or two or three max, the body goes into a more parasympathetic function. So basically, the stress goes down. Okay, that's good, but that's all that happens for a long time. It's like the body, is judging or gauging. Okay, we're grounded. Is this going to be just ephemeral things, or it's going to last? So when it lasts about 20, 30 minutes, it gets enough electrons and it says, well, this is real. We're really grounded now. So it starts to be changing the physiology. So that's when, for example, you would have electrons going into a region of inflammation and decreasing inflammation. Like it takes about 20 to 30 minutes also to see through thermal imaging that the inflammation has gone down in a region of the body. And this corresponds to the change in blood oxygenation going up, respiratory rhythm changing, cardiac rhythm changing, all of these things corresponding to an adjustment of the physiology of the body. So we have that in correspondence with, the inflammation going down. And the conclusion is that there's physiological changes that are important, happen about between 20 and 30 minutes after being grounded. So that was a paper, pretty interesting paper that we published that actually capture the important information of the physiological changes. But we see, like the SoCals also have seen lots of physiological changes in their papers. There's other papers, like, for example, we have 3 or 4 papers that shows that you change blood viscosity by grounding. So that means that the heart has to pump blood that is just like wine versus ketchup when you're not grounded. So it affects tremendously the autonomy, the cardiovascular system and the heart itself. So
My understanding is that the ground substance or the extracellular matrix, basically this space between our tissues, between the cells, is essentially the repository for excess electrons. We have these very long glycosaminoglycans that are capable of storing large amounts of electrons that can then be mobilized when needed. And essentially, I would think what's happening when we haven't been grounded for a long time is that those stores get used. And that 30 to 40 minutes before we really start to see the best effects is essentially like plugging the battery back in and recharging it, filling up our extracellular matrix with the charge that it needs. And I mean, it's difficult to think about the extracellular matrix without water because, of course, it is completely hydrated and water plays a very important role in that. How does this story about basically charging the battery sort of align with the work of Gerald Pollack and his notions of easy water, this splitting of water where it becomes positive and negative, and it shows crystal structure?
Yeah. Well, what Gerald Pollack shows is that when you have water next to a molecule or a substance, there's a charge separation that happens, close, and it creates an easy water, So basically, one charge, I forgot which one, I think that the positive charge I expel and the negative charge staying there. I think that's what it is. And you can actually use that to make it a battery. But what I'm surmising is that probably because there's so many molecules in the cells and they're so small, that most of the water inside our body is probably easy water. So that means that there's electromotive forces, that creates, for example, that helps, for example, the cellular maintain a potential difference between the external and internal of their, to 70 about millivolts. And I know this ion pumps and stuff like that, but I think easy water inside the cells and outside the cells play a role also on all of that. So, and I think as we lose our charge, our water become less charged itself, and the easy water turn maybe into more just ordinary water, and that decrease the cohesion, of the whole body. Basically, the body becomes the tissues become less firm, and all of these things happen with the old age. And I think we have evidence showing that, being grounded all the time helps slow the aging process. So myself, not very young, and I'm feeling really good. I'm going to be 69.
It makes sense that having that repository of electrons there all the time basically just helps your body respond adequately to the environment that it's in. And one thing that I want to go back to. Oh, sorry. Yeah, you can go ahead.
Yeah, I have one thing that is interesting. That is a pilot research, a very small pilot research project done by Andrew Doan. Basically, what he did, he put his body under a high power line. Okay. And so he measured himself, the voltage between him and the ground, and it was very high, like 17 volts. So that means that it's really high power voltage there. So then he ground himself for a week and come back, and the voltage is down to 14 volts or 15 volts. And then he grounds more, and as more he grounds, the voltage that generated at the surface of his body is less and less, down to 10 volts. And he thought that was interesting. So he repeated that with one of his friends who has never been grounded. So basically the same thing, 17 volts or something, whatever. And then grounding, and the voltage come down with time when the person ground for a long period of time. So I think what's happening there is that when the person with time, so when the person is discharged, he has little electrons, then the effect of the on the surface of the skin of the electromagnetic field at 60 hertz is maximal. Nothing, prevented. Basically, what happened when you're grounded is that you have first you have to be maintained at the potential of the Earth. Second is that the electrons will come and interfere with the electric field, so basically cutting it. So when you have some charge inside, a little bit of that can happen. So the more you are charged inside, the more some of the electrons can come on the surface and mitigate, the effect of the electric field of the 60 hertz. So that's why you have, a decrease in the voltage due to at the surface of the skin, even when you're not grounded. I think it's because this is, to me, I found that very interesting because it's an indication that we're building up charge inside when we are grounded. The other indication that is interesting is that if you're not be grounded for years, a long time, it's going to take time to build up completely, recharging your battery. It's not going to happen in an hour. I mean, the process will start. But it looks like we need like 2-3 months of grounding regularly to really charge our battery to a high level. There's another experiment that was done with Dr. Sinatra that is kind of along those lines, is that he had a microscope and a dark field microscope to measure red blood cell clumping. And so he said, okay, let's measure everybody. And he wanted to see the effect on red blood cells. That was before we knew anything about the blood viscosity stuff. So this is actually the experiment who started us on blood viscosity. So what we did is, what he did is have people, get their blood out. Everybody has their blood clogged. And so after half an hour of grounding, their blood looks much better. There's only one person who started immediately with good blood. It was Clint Over. Even though he was not grounded for many hours because he was traveling, his blood was still good because he's been grounded for 10 years or 15 years before. So his batteries were fully charged.
And my understanding is that no one would accept that paper for publication because they didn't believe it.
No, because and also it says, oh, it's just observation.
Yeah, right.
And that's why I had to do some research to find something that is a quantity that is measurable called zeta potential. So I did the research around that. I had exactly this thing in mind. If we want to publish, we need something more solid, more scientific. And so I found that we could measure the zeta potential, and then we were able to publish papers.
So zeta potential also comes back to this blood flow problem where if the endothelium is negatively charged, which we know the glycocalyx is negatively charged, and the red blood cells are very negatively charged, they're going to flow very seamlessly because they repel each
Exactly.
other.
Exactly.
And this is a big problem with hypertension. It's one of the biggest causes of cardiovascular deaths, and
Exactly.
it can essentially be mitigated by exposure to the electronegative surface of the Earth as much as possible.
Yep. Yep. You're exactly right. So it prevents a lot of cardiovascular problems.
These dark field microscopy photos, these before and afters, are really fascinating because it's so stark. But I've also seen someone who's an acupuncturist do the same thing, and the
Yes, I
same
know him.
results, the same results
The same
after
results.
acupuncture.
His name is Simon Kamei. He's in Hawaii.
And I was wondering what you think of that, because obviously from traditional Chinese medicine, they talk about essentially moving energy and unblocking things within that flow system. How does that connect from your point of view with the earthing story? How is that basically supplying the charge that then goes onto the red blood cells after acupuncture?
So you have to understand also that we have, the feet are exquisitely designed to get electrons from the earth. There's only one acupuncture point there, which is kidney 1. And so the kidney 1, so it seems to me, and we have a paper on that also, that explain that theoretically. We don't have all the evidence, but that the kidney 1, the kidney meridian, the electrons flow through the meridian system. It seems that the meridian system would be a good system, and the kidney is connected with the urinary bladder meridian, which is the longest meridian in the entire body. It goes all the way to the back, all the way to here, behind the eyes. But in the back, it connects with all the other meridians of all the other organs. So it's a perfect one to spread electrons. So what this acupuncturist does is grounding his needles.
Ah, right.
He used grounded needles, and he has excellent results. I was there during the holiday period, not in 2022, the end of it. And his clinic was buzzing like crazy. And I've got treatments from him, three treatments of acupuncture with grounded needles. It's fantastic. And so the people, word of mouth, is going. This acupuncture is somehow as, some magic trick, and it's earthing. It is. So I do think that because in reality, when you do acupuncture, you have a metal needle there. So by having a metal needle going into the body, you generate an electrical potential between the needle metal in the body. So that's really, and then you twist it so it does, something. It's like when you put two metals next to each other, they create a voltage between the two of them. That's the principle of the batteries, actually, because their electronegativity is different. So, the extraction potential that is needed to get the electrons out of a metal is different for every metal. So you have this kind of electromotive force that is created automatically. So why don't take advantage of that and ground the needle? And I think then you get electrons on top of that. And I think it's just enhancing from what the experience is with Dr. Kamei. It's just enhancing the experience of being doing acupuncture.
That's so fascinating. I was wondering, I suspect you're going to say, earthing with your feet on the wet grass or any sort of damp surface is going to be the best way to
The best way? No, it's not that.
In the ocean?
It's good. It's excellent. In the ocean, naked in the ocean, because the water in the ocean is all charged with negative electrons. You get electrons from all over the body. And on top of that, you get negative ions that you're breathing in from the ocean. and you get the sunshine. So I live in Encinitas, which is a surf town. It's amazing how, these surfers are addicted to go surfing 6 in the morning. It doesn't matter, winter or summer. I mean, they go out there, and the temperature may be only 10 degrees. They're still going to go down there and do their surfing in swimsuits. It's addictive. I have a friend who's a surfer like that, and he said, my day is not the same if I don't do that. No, it's not as good. So, and I understand why. I mean, it's the best way to get electrons. You get sunshine, you get vitamin D, you're breathing in negative ion, and you're moving so that you get all this charge moving inside your body. You know, I mean, it's probably one of the best exercise to do in the morning before starting your day that you can imagine.
For many years, I've thought that a lot of the epidemiology surrounding sun exposure and skin cancer has not taken into account the fact that when we're exposed to the sun, obviously our body is expecting to be earthed, and
Yep.
any damage that might be coming from the exposure to sunlight that has those short wavelengths of light is probably going to be offset or controlled by the earthing process as well. And I often think, we have all of these studies, these models of animals being exposed to UV light. They're never earthed. So,
Yeah.
for me, those studies don't really take into account how the human body is actually supposed to respond to exposure to sunlight. And I
In
think
the natural environment.
exactly in the natural way, because we would have never been exposed to sunlight whilst not also earthed at the same time, supplying
That's
those
right.
electrons and supplying that information.
That's right.
So, I think that this story actually plays quite a large role in understanding the role of sunlight in human health as well.
Mm. Because the sun is not is the same sun. I mean, it has this 11-year cycle goes up and down, but it's doing that for millions and millions of years. So I mean, the sun going up and being stronger, which has been, in the past years, yeah, give more UV, but the body should be its normal state should be able to take care of that.
Yeah,
Now,
absolutely.
apparently, that according to NASA, the and NOAA actually, the the next decades, the sun will, even on the sunspots, will not be as high as it's been in the past. So we're going to have cooler temperature. So you'll see the narrative change from, uh, too warm to too cold, like we had actually in the 70s or 80s,
Right.
that we're going to a cold spell. And now we're going to a warm one. And now we're going to go to a cold one. It's just natural. The
Interesting.
body is
Yeah.
used to that if we are grounded. And by the way, it also helped mitigate the effects of Wi-Fi and all of these high frequencies. They're not stopped like the 60 years. You're not going to see a drop in these because they're too high frequencies. The electrons at the surface of the body or the other molecules, charged molecules there, they cannot respond to a high frequency. It goes in. But being grounded will help the repair mechanism just like it does for UV in natural light.
Yeah, that's very interesting. I've often wondered, obviously you can watch your total body voltage drop, but at the same time you're still being exposed to, these other wavelengths, these other frequencies
Yeah,
from Wi-Fi and cell towers and whatnot. And I
yeah,
thought, well, I wonder what it's really doing to those. But obviously, like you said, all you can do, you can't turn those things off. Well, you can turn the Wi-Fi router off, but you can't turn your neighbors or your upstairs apartment their Wi-Fi router off. But what you can do is basically give your body the best chance to regulate itself against those
yeah,
while you're being exposed. And that sort of
yeah,
brings me to the idea that there are a lot of these products that you can use a stake, put it outside, and then run the wire inside, plug it into, a mat that you can put your feet on, or sheets that you can put on your bed that have silver thread in them. Are there any? I know there's quite a debate about whether it's safe to use an outlet,
mm-hmm,
the grounding point in the outlet.
mm-hmm.
I've always erred on the side of caution and used a stake in my garden outside rather than using the outlet. But Is there any potential danger of using the outlet even if you use an outlet tester that comes with a lot of the products that you can use to see that they're wired correctly? Are there still risks?
Well, the first risk is there is some risk, because the risk is that uh, you have you can measure that there is a good ground using a ground checker, and you will have a good ground. But you can have miswiring. Like, for example, in some places, what they do is they connect together at many points the neutral and the not the live, but so you have the neutral, and you have the return current. So the neutral, yeah, the neutral and the ground. The neutral is the one that is the return current. So these should not be connected more than one point at the entrance of the building, just for safety feature. So, but that creates normally a small voltage on the ground wire of about 1 to 2 volts.
Right.
At 60 hertz. So for normal people, it's not a problem. But for people who are electro hypersensitive, it could be a problem. For me, for example, I'm not able to put a stake outside. I was actually at another place I live, but for the past 20 years, I could not do that. So I use the outlet. I've been using that for at least 10 years. No problem. I think this building was built in the mid 80s, so it's probably well built. And I check it also. There's a way to check it by checking the voltage on the ground wire of the building using a stake outside and measuring the voltage difference between the two.
It should be zero.
It should be zero, but at least in North America, the way it is, you should have about 1 volt.
Right.
1 or 2 volts maximum. If you have more than that, that means there's miswiring.
Yeah.
And if you have 1 volt of 2, a battery of 1.5 volts, you put your finger there, it's not going to kill you.
Yeah.
So it's not a big deal unless you are already impaired and are electro hypersensitivity sensitive. So that means your autonomic nervous system is totally out of balance with super stress and anyway. So yeah, there's a little bit of cautions when you use the inside. The ultimate thing is to make sure that the voltage, even the ground is good. So you have an instrument to do that. And a little more complex is to measure that the voltage on the ground wire compared to the real ground is no more than 2 volts.
Yep.
And if you do that, then you can use it, because the ground itself of a building is a really good ground. Most of the buildings built after the 80s, they have what is called UFER ground, UFER. It's a way to make a long rod 20 feet into the concrete that make the basement of the building. It's really good ground. So if everything else is okay, this ground is even better than it, unless you have a stake that's 10 feet long, within that in the ground. This ground is better. The only thing is you want to make sure it's a clean ground. Now, the other thing is that people think about dirty electricity, right? And that it's a problem that, like you have appliances on and off, like the fridge and even some lamps and stuff like that. Where you are grounded, it's not really a problem, because the frequency is low enough that the body is able to mitigate that. And we have research that shows that. So basically, the spike that you can find, in the current that results in spike in the electromagnetic field in the environment, maximum is about 10 kilohertz, maximum. Normally, it's less than that. Well, the body can respond up to 100 kilohertz. So mitigate that and prevent that for entering. So really, the dirty electricity is not an issue for if you have a normal ground and if you are a normal human being. Again, if you are highly hypersensitive, you could feel something. And
how much caution should be taken if you think about your proximity to, say, a substation or a cell tower or high voltage power lines. I know Steven Sinatra has said it's probably not a good idea to try and earth near high voltage power lines, because if you put your bare feet on the ground over there, you might not be getting the effect that you want. What considerations need to be made there?
Okay, the bigger consideration is this. If you have a high voltage power line on top,
Mm-hmm.
Dr. Doan has shown that if you ground there, touch the ground, you're protected. It goes to zero, just like, so it's not a problem. The problem is that these high voltage are very powerful. So if you're not grounded, you get 17 volts. That's a lot of voltage on your body. When normally in the home, when you have lots of voltage, you might have like 5, 6, 10 volts max. Normally it's less than 2 volts. So it's a high voltage. The second thing is that if you are close to actually an electrical power station, which is very unusual to have a house close by that, within 100 feet from there, then the potential of the ground is a gradient potential, because all of this. So then when your feet are separated, you can have a voltage between your 2 feet, and that's not good. So you don't want to be close to that. The same thing could happen with electric trains. The tracks could have caused some potential, difference potential in the ground. The third thing is lightning. Lightning, can create very large difference of potential on the surface of the earth, thousands of volts, being the more positive where at the center of the storm, and then goes more negative. And in fact, that's why we have a warning that if you live in a zone where there's thunderstorms, never ground using 2 different methods of grounding. For example, there was this lady who had her bed mat, grounding mat on her bed, that was put outside and grounded through a stake, outside. Then during a thunderstorm, she decided also to put a band, a grounding band around her ankle and ground that to the house power outlet. Now, the grounding rod of the power outlet or the house is at one location. The one of the stakes is 30 feet, 40 feet away. So when you have this thunderstorm and you have like lightning, and you have this huge difference of potential, there could be thousands of volts. Thank God that there was 100 kiloohm resistor that burned. So she just have a little burn on where the resistor blew up, to protect her. So that's one thing not to do. I mean, she could have plugged, instead, if she could use any outlet inside the house. They are connected together and they go to the same stake. That's not a problem. It's the fact that she had a stake outside that create a potential between 2 grounding rods. And that could be a problem in thunderstorms. But other than that, I've given you pretty much what I know, that the cautions that we need to do. Other than that, it's pretty safe.
So where is the research headed from here? What are you working on at the moment?
Well, we are very active in finishing the certification course.
Mm-hmm.
So level 2 will be coming up soon. Level 3 probably next month. So we're working on that. We're working on research projects with pets, animals. So we have someone interested in that. And in fact, in the certification course, the person I was working with, who is a woman that is actually the rep for South America, I'm sorry. She's also a vet. So we're going to meet and do some experiment on veterinarian. We have also experiment going on that's going to be published soon on the effect of grounding on mitochondria themselves. Because that's very important, because mitochondria is the energy source of the cell. We know that earthing gives you energy also, makes you more energetic. And It can do that only through the mitochondria, because all the energy of the cell is to mitochondria. So we just finished a study on mitochondria that will be published soon. And we're planning more research on mitochondria in the near future, because it's a very important topic.
Absolutely, that's fascinating. I'm glad you're looking into that. I look forward to reading those papers.
Do you have a background in biology in some way?
Not particularly. I have a degree in nutrition, but I've been extremely interested in all of this for a very long time. So
okay, you seem to know some things. That's what I'm asking.
Well, thank you. Yes, I hope I know a few things. That's the whole point, and I hope to share that with people as well. Share your knowledge. So I'll be cautious of your time. So thank you so much.
Well, thank you for having me, and really enjoyed this time with you.
Thank you so much for listening, everyone. I really hope you enjoyed this episode. If you'd like to follow Gaétan's work, I've left some links in the episode notes for you to explore. I would also encourage you to subscribe to the podcast, leave a review, or even a thumbs up, as it really helps me grow the channel and reach more listeners. The bigger the channel gets, the more guests I can reach out to. Please feel free to follow me on social media as well to keep up to date with new podcasts and health-related information. Thanks again for listening, everyone. Take care.